This episode is called The Atom, the Augmented LLM. Retrieval, tools, memory, three names for one mechanism.
So, actually, Anthropic defines it in one sentence. It's the basic building block of agentic systems, which is an LLM that is enhanced with augmentations, such as retrieval, tools, and memory. So it's not a framework, it's not LangGraph or LangChain, it's not a loop, it's a model with three things bolted on. Here it is as a picture. The model in the middle, as you can see here, you have your retrieval, which pulls in the vendor record, and then you have the tool here, which does the call read on the invoice. For example, 41117, which came from here, and then you have the memory, which holds on to the invoice it is currently working on. So 3 arrows, one model, and that is our invoice atom. Thing is, here I'm saying it reads a clean digital invoice, checks the PO, returns structured fields. The problem is that here we have a qualifier, which is clean and digital. In 2025, benchmark models cleared 96% on clean invoices and 98% on clean header fields. But line item tables fell to around 57%, and scans degrade. The atom is strong, it's not a document AI silver bullet. So as we said many times before, it's the data quality and your infrastructure and your coding around your LLM, of course. So why start here? Anthropic writes, for the remainder of this post, we will assume each LLM has access to these augmented capabilities. So every pattern in the series sits on top of this thing. You need to understand what is the atom that we have, and then from there you're gonna build on. But this is our atom. Now, the part I actually want you to remember, and this is based on everything I've been talking about until now. Let's talk about context. So, context, defined by Anthropic, is basically the set of tokens included when sampling from a large language model. So, it's basically when the LLM is gonna be answering a question, what's the context that it's using? It's the amount of tokens that you're inputting, basically. So ask the same two questions of each augmentation. Where do its tokens come from, and what decides when they go in? So retrieval, here, tokens come from a document store, and you decide before the call, and then you have tools, which come from a live system, and the model decides mid-call, and memory, it's the past session, and the policy decides what to keep from the previous session, of course, in the new session. One thing that you need to remember is that they all end up tokens in your window, and that's very important for us because here you need to understand that this is a very delicate art. So the capacity to control, to differ the source and control what gets inputted as in your context window for your model is a very delicate art that needs training. So, and here is the scaffolding so you can check my work. Anthropic gives us context equals the set of tokens. Karpathy in June 2025, he said, context engineering is the delicate art and science of filling the context window with just the right information for the next step. And LangChain, for example, they have their taxonomy, which is write context and select context, and they treat memory, RAG, and tools as parallel cases of the same select into the window operation. Nobody states the full reduction. I think it is the right lens. And once you have it, every memory feature and every RAG pipeline you ever meet is the same question wearing a different hat, which is, hey, what's the context? How would you be able to control that context for your LLM calls? So, how do you make your atom good? Anthropic actually gives two recommendations. And the second one is where the actual engineering is hiding. So, tailoring these capabilities to your specific use case, ensuring they provide an easy, well-documented interface for your LLM is very important. Second, they put a number on how much that matters. Think about how much effort goes into human-computer interfaces and plan to invest just as much effort in creating good agent-computer interfaces, just as much. And the instruction underneath it is put yourself in the model's shoes. So their own example is almost embarrassingly small. So they had to build an agent for a software engineering bench, and the model kept making mistakes with tools that used relative paths. Once the agent had moved out of the root directory, of course, problems occurred because they were using relative paths. The fix was not better model or clever prompting, they just changed the tools to always require absolute paths. And in their own words, the model then used this method flawlessly. So it's not, how to say, it's not really magic or some really complicated maths. They just gave it the full paths because the model just kept going out, and I think this is a very obvious and easy problem to understand. They say outright they spent more time optimizing their tools than the overall prompt. The model was never the thing failing, the interface was. So basically, one thing to understand is that you, as an engineer or as a agentic AI engineer, you're going to be spending most of your time actually doing data engineering, not training your own model or such things. It's mostly data engineering. This has a name and a measured number. Software engineering agent formalized the agent computer interface, and redesigning the interface alone took software engineering bench from 3.8% to 12.5% by redesigning the interface alone. So just by redesigning, they did 3 times, excuse me. Same class of model. They were using the same class of model. And this is the work everyone is avoiding, No. Why does this ordering matter? Every pattern ahead is atoms wired together. Chaining is atoms in series. Parallelization is atoms side by side. An agent is one atom in a loop. So wire 3 weak atoms in a series, and you do not get one strong system, you get the weakness, but 3 times multiplied, you just get garbage in, garbage out. This is the same thing I've been saying for a long time. And with more tokens and more latency, actually, so it's catastrophic. Which is why Anthropic says, for many applications, optimizing single LLM calls with retrieval and in-context examples is usually enough. And to be careful, the failure direction, weak atoms, poison any topology, is my logical extension of their compounding errors line, not a verbatim claim they are making about topologies. But it's obvious here. So there is a measured version of this from 2026. LangChain changed only the scaffolding around a single call. So the system prompt tools middleware with the model weights untouched, and the coding agent went from 52.8% to 66.5% on terminal bench atom level work. Double digit gains, no topology change, and I will give you the counter lens honestly. A 2026 school of thought says agent equals model plus harness. That the loop and its scaffolding are what really decides performance. It is compatible with the episodes that we have been talking about until now. The harness is the loop layer, and the atom is deliberately the pre-loop unit. So note, this is actually practitioner writing, not really peer-reviewed research or whatever. So the harness here became part of the agent. It's a new part of the agent's definition. So the order of work is fixed here, and Anthropic states it in one line: start with simple prompts, optimize them with comprehensive evaluation, and add multi-step agentic systems only when simpler solutions are not doing the trick. So here we have 3 fences, because each of these gets confused constantly. First, you have an augmented LLM is basically not an agent by definition. That's coming from Anthropic. LLM is using tools, but for something to be called an agent, there needs to be a certain feedback loop. And if you have just the atom, like just the LLM that runs, maybe gets retrieval and stops, that's not a feedback loop. Second, tools are not MCP. MCP is a protocol for connecting tools. It was announced in November 2024 and donated to the Agentic AI Foundation in December 2025. So the augmentation is the tool. MCP is the plumbing around to make the connection between the different tools. Third, memory is not context engineering. Memory is one augmentation. Context engineering is the whole discipline of curating the window. So Anthropic basically calls it the natural progression of prompt engineering, and it gets, so we will talk about this even later. Now, we have 3 vendors, and each of them have different definition of what is an agent. So here for Anthropic, it's model plus retrieval plus tools and memory. Google, it's model plus tools plus orchestration layer. OpenAI, it's model plus tools plus instructions. They all have basically the models and tools in all of them. But then after that, what the disagreement is about the memory, where the memory lives, how to call it. So I don't think this disagreement really matters, or if like the debate is really interesting here, because at the end of the day, it's a token. So it's an input token for your agent, and you need to decide if it should be there or not. And memory formally, you have short term, which is working memory. It's the current context window. Long term is the external store persisted across sessions and pulled back when it's needed. For example, CoALA splits CoALA that splits the long-term store into episodic, semantic, and procedural chunks. This was actually coming from the paper in NeuroIPS in 2020. So all of this is interesting. Now, to recap what we did until now, you should be able to have a test where you could know if a certain product feature could be called agent memory or not. Or let's say you look at a product feature and it's called agent memory or RAG pipeline, for example. And you should be able to ask 2 questions. Where do the tokens come from? And what decides when they go in? If you have a vendor that cannot answer those questions, well, they vibe code the shit out of their product and it will suck. In my experience, there are levels of vibe coding, and if they can't answer these questions, they have no idea what they are doing. And then 3 things to keep in mind. The atom is the unit, model plus retrieval plus tools plus memory. You have 1 call and no loop. So this is the atom of your architecture. All 3 augmentations are 1 mechanism, tokens into the window, differing only by source and write policy. And the interface is the real engineering. So we spoken about this example when they went from relative to absolute file paths. It was more than the upgrade. It netted better results than the upgrade than a model upgrade, which is very, very interesting. Let's say it that way. So that was our episode for today. Please like and subscribe and follow me on LinkedIn. Thank you. Have a nice day.